Hi everyone, Greg here. How are you doing today? Okay. Correlation coefficients and significance. Now, the one thing to keep in mind is that I've got a set of data pair here. I've got 1, 4, 2, 4, 3, 5, 4, 4, 5, 5, 5, 9. So let's say this is the number of carrots you eat per week, and this is the number of miles you run per day. And I put the pairs in the correlation coefficient calculator, and I got an R correlation coefficient of 0.7444. Okay? Now, that looks like it's a pretty good correlation coefficient. But don't forget, R is just the correlation of a small set of samples out of the entire universe. So, if you took the entire set of amounts of carrots you could eat and the possible number of miles you could run, you wouldn't just continually to eat carrots and hope that you could run more miles, even though that correlation is pretty strong. You would have to know how likely it is that that correlation holds for a whole population, because this is just a small sample. And the way you do that is you test the correlation for significance. Now, first of all, if I take the calculator, the significance of correlation calculator, and I put in an N of 6, and I put in an R of 0.744, it tells me I get a non-directional P of 0.0899. Now, what does that mean? 0.0899. Let's move that over here. What that means is that if I start out with my standard alpha of 0.05, that's the minimum probability of committing a type 1 error, then I can reject the null hypothesis. I cannot reject the null hypothesis that there is no correlation in the general population. So let's state that again. For a correlation, the null hypothesis is that there is no correlation in the general population. So the combination of the R and the sample size has to be pretty big to reject that. It's been a long day. Let's make sure I got that right. Okay, our P is 0.8, which is not smaller than the alpha, which means I cannot reject the null hypothesis, which means that I cannot reject the notion that there's no correlation in the population in favor of the alternative, which there are, simply because the sample size is too small. So that's something to think about. Don't get that confused when you're doing your work. And it makes sense in terms of sample size. It makes sense in terms of all hypothesis testing, because the larger the sample, the more sure you can be about your conclusions. Okay, well, that should clear it up a little, and thank you for all your good work, and have a good day.